Manufacturing the future is our next presentation. This is also going to kind of pick up on where we've been going this morning. And if you could, please give a warm round of applause to the Executive Vice President and CMO of 3D Systems, Miss Cathy Lewis. I think she's here.
Okay. That's okay. Hello, everyone. Wouldn't you know they would give me the lunch break? But that's okay. We're going to have some fun because 3D printing is a really exciting technology, and it is completely transforming every aspect of our lives. I have a quick question for the people in the audience. How long has 3D printing been around? Guess? Years? 3 years? 5 years? 10? 20? Do I hear 30? Well, it has been 30. And this is the first 3D printed part. And while it's not exciting, it is 32 years old. It was created by this gentleman here, Chuck Hull. And it took him about 5 years of playing back and forth with various materials to try to find how to get them to stack. And then from there, he created the first 3D printers that literally create whatever object you have imagined or designed layer by layer. And Chuck founded the company 3D Systems 30 years ago, next March. So it's been a pretty exciting time. And what Chuck did with that idea was he created a method to prototype, to rapidly turn around a new design, a new idea, no matter how simple, no matter how complex. But he took it from a process that would have run anywhere from 6 months to 5 years, depending upon the complexity and the industry. And he was able to turn it into hours, days, as a trade-off, and help companies anywhere and everywhere get their products to market faster. So from the shoes you wear to your eyeglasses, the car you drove in, the airplane that I took to get here, all of these products get to us today through 3D printing. At one stage or another, they are either a concept model, a prototype, a functionally tested prototype, or an end-use part or product. So pretty exciting and pretty dramatic change to product development. But one of the things I'd like you to think about today is 3D printing is an interesting industry. Yes, it's been around for 30 years, but it's still a relatively small industry. But I'd like you to picture it sort of at the center of the manufacturing world. Because we don't believe that 3D printing is going to destroy manufacturing. We think it's going to be a critical component of it. We think it's going to allow people to choose when and how they manufacture. We believe it's going to help people manufacture closer to the local market. And we know that it's going to help people create product that cannot be created any other way. Okay, now I want you to really think about that. There are some products that it's impossible to manufacture in a traditional way. And 3D printing changes all of that. That's what's really magical about it. And that's why there are lots and lots of 3D printers available today. And there's a range of price points that start at under $1,000 and still go up to $1 million, $1.2 million, depending upon the type of technology and usually the size of the build envelope that you're going to be using. And also maybe the material that you're going to be using. So wide access today, and we're continuing with other companies to push the access as far down to the marketplace as we can get it. So the real magic, which we've discovered after the rapid prototyping revolution, was that with 3D printing, complexity is absolutely free. The printer doesn't care what you've imagined, it will print it for you. The printer doesn't care if you give it 25 different items to build in the same build envelope, it will print all 25 of those for you and they will be exactly as you designed them. And they will be in the material that you've chosen. So, and why is this important? It's because there are a lot of applications that cannot be properly addressed today with traditional manufacturing because they're too complex, because they're too detailed, because they're too organically shaped. And that really requires the power of 3D printing. So let's talk about a couple of those applications and how the system has already transformed certain industries. In-ear hearing aids used to be handcrafted. They were built and put on a shelf. They were purchased, and they were rejected 50% of the time. Very expensive value proposition. With better scanning, all of the in-ear hearing aids are now 3D printed. The electronics are stuffed into them, and they're comfortable. Compliance has skyrocketed. And oh, by the way, all of us are going to face some type of a hearing issue in the next 10 years based on the way we consume information and music, et cetera, today. So this is really good news. Invisible aligners, those used to straighten teeth. You used to have to put metal in your mouth. There were no other choices. But with 3D printing, you could take and transform that industry and leverage little invisible aligners that are custom made for you, maybe 10, maybe 18, depending upon the condition your teeth are in at the point of taking this therapy. And today, this is done in a factory, lights out, with 3D printers. And last year, they printed over 20 million individual unique aligners. That's pretty magical. So that means that this is not just an exciting technology that can produce whatever you send to it, but it can also scale and begin to create new methods of manufacturing. And that's pretty powerful. Again, this didn't replace a manufacturing process because in the mouth, metal braces were pretty much handcrafted as well, but it created a scalable manufacturing process to customize for you. Now, when I think about where that could go further in terms of the healthcare industry, think about implants. Think about medical models. So when your physician has to explain your prognosis and what he would like to do or she would like to do to treat your condition, wouldn't it be nice to have a model for them to share with you, for you to actually see what they're talking about? I can tell you that in many cases, the medical model has helped physicians handle a surgical procedure that they couldn't have done before or they wouldn't have been comfortable undertaking with very young patients, very small individuals, and in the cases of conjoined twins, it can be very, very complicated. And about 11 years ago, they used a medical model, studied it for 2 weeks, and then deployed it inside the surgical theater to separate the Egyptian boys that were joined at the head. And the doctors did take 30 hours to complete that surgery, but they said that the medical model tremendously helped them get it done, and both boys are thriving today. Whether you think of any other implication, an aging population, we're going to need these implants. We're going to need the access to made-for-me, fit-to-me types of appliances over the course of the next 10 years, and it's all going to be made possible with 3D printing. Now, one of the things that's fun about this is it doesn't just apply to the human condition. We happen to have some other friends that have needed implants or have needed prosthetics and have needed some custom applications to really help them thrive. And we've been able to leverage 3D printing to do some custom work. This happens to be Derby, and he was born without full front legs, a very unique condition that didn't really lend itself well to the use of the carriages that they put dogs on that have hind leg problems. So we were able to complete an assessment, create some customized prosthetics, and you can see Derby struggled with the carriage, but today Derby is running and gunning based on custom prosthetics. And it's funny, this particular video has received millions and millions of hits because of the power of how we feel about our animals and using the technology for that purpose. Now, of course, The use of the technology is much broader than Derby, and it's much broader than prosthetics. We recently introduced a case study where apparently the cruciate ligament in dogs is extremely sensitive to either damage, aging, or malformations, overbreeding. We now have a direct metal implant that has been used in over 10,000 dogs to improve their lives and correct the cruciate ligament problem and have them back up and running in about 6 weeks. So it's pretty exciting when the technology can help not only you, but your best friends. And here you get a chance to see Derby adopt to his new legs and take off and start running. So I'm going to give you a second to look at that. And of course, we've tried to get Derby on television, but the owners don't like to take him too many places. But he will be at the White House next week, visiting with the president at the science fair. So just one of the amazing uses of the technology. And because Derby had not had the use of his front legs, we had to elevate him slowly but slowly with the prosthetic so that we didn't injure the back. But again, one of the wonderful uses of this technology. Another area that's really important is in malformations, problems with any of the people that we care about and love. And in particular, young girls suffer from scoliosis. It's a very painful problem for them to have in their teenage years. The remedy is a brace that they don't like to wear. It's very uncomfortable, it's very hot, and people know when they're wearing it. So we can customize and form fit these beautiful braces, and it almost becomes a fashion statement for these young girls. What an amazing way to change a life and help them avoid the surgical process, which is not only expensive and painful, but also has them back in a brace for some period of time. So this, again, talks to the organic nature, the ability to print very complex objects, and to do it in a way that's fit just for me. But of course, we've impacted lots of industries and lots of people. In this particular case, Amanda Boxtel was actually paralyzed from the waist down in a horrific ski accident about 20 years ago. And through a lot of other miracles in medicine and applications, she has an exoskeleton robotic suit that has now gotten her up and walking. The problem with the suit is it can't be custom fit to her body on its own. So what we did is we scanned Amanda's morphology. We created custom implant devices to go onto the exoskeleton. They're form-fitted to her body. They protect all of the critical areas of her physique where the suit was putting too much pressure on her. Pressure that she couldn't even feel personally, but would abrade her skin later on. So that has enabled us to truly take a robotic suit that's a miracle in and of itself and custom fit it and make Amanda's life just that much better. And today she talks about how her next wish is to walk in high heels. We've got a little bit of work to do on that one. But it is exciting when you can change someone's life with the technology. Now, going back to the more mundane, of course, we've been dealing with the aerospace and defense industry almost from the beginning of 3D printing. If you talk about complex things that need to fly, if you talk about getting into space and having to really think about weight and what's going on with that product, this is why companies like GE have dedicated billions of dollars over the next few years to 3D printing technologies. This is Jeffrey Immelt, and he's talking about the next jet engine and how important it is to reduce weight. And if you reduce it only by 9 to 10 points, you're going to save billions of dollars over the lifetimes of those engines for those customers. And of course, they have some very powerful, very important customers. So for GE and others, using 3D printing to create better blades that are more aerodynamic, reducing the fuel burn, being able to create fuel nozzles that have a 90-degree turn in them that probably couldn't be generated in mass with traditional manufacturing, are going to change those jet engines, which will launch next year, and again, allow them to reduce fuel burn, saving billions and billions of dollars. And they'll continue to invest in factories around 3D printing for that very reason. I don't want you to think, though, that this type of technology is really reserved for the companies with the largest budgets, because that's not true. This is a company in Washington State that happened to have been founded by a bunch of rocket scientists, and they wanted to create a space vehicle in a very short period of time, very affordably, that could go out and start to really scope out the asteroids, begin to capture them and bring them back, and then harvest asteroids for precious metals. Sounds wild, but somebody's got to do it. These gentlemen were able to create this space vehicle. It has less than 20 moving parts. They did it in under 2 years. It's already being deployed, and the cost is a few $1 million. And of course, had this been left to the larger companies, it might have taken 10 years and billions of dollars to get there, and I'm sure it wouldn't have 20 moving parts. So keep in mind that once you are sort of set free from the traditional design constraints of designing for manufacturing, and you can design for perfect function as you can do with 3D printing, all bets are off. You have tremendous potential to really change the world. So in order to make this tremendously accessible to everyone, what we've done is work very closely with, of course, the automotive industry as well. They were the early adopters from the rapid prototyping scenario. They used the technology to turn around new models in a much faster time frame and to make them sexier, to make them more successful. Then they moved into using the technology for bridge manufacturing. So if, in fact, the manufacturing line was not up and running, they were able to produce some on-car parts and get the test cars out on the road earlier. And today, what we're seeing is a lot of customization. So you can pick a lot of different things in a Mini Cooper, and some of that is going to be made possible through 3D printing, and that's today. We know that that's going to continue to improve and increase over time. So a lot of exciting things going on in the automotive industry as well, one of our more traditional users. So one of the next most exciting things that's happening in 3D printing is the movement to metal. So direct metal begins to change the paradigm even further and allow more direct manufacturing of parts that have to be done in metal. These machines will produce relatively small to mid-sized parts today in 15 to 16 different materials. You see a lot of aluminum, you see a lot of tungsten, you see a lot of titanium, and you again see two major users early in the process, and that would be aerospace and defense and healthcare. But as these machines begin to populate more and more of the manufacturing facilities, I think you'll see lots of different companies using them and taking advantage of them. My bracelet was 3D printed in the direct metal printer, came right out of the build envelope, and I can wear it. Not necessarily the way most people will use the technology today, but very exciting when you see the changes in the technology and the adoption of a wider group of materials. So the message here is that the technology is exciting. Software is really important to it. There's a process element in 3D printing, but materials is another place where there's a lot of magic. So today, as a company, we offer about 120 different materials. These start in waxes, different plastics, different polymers, some with different flexibility factors, going into casting materials that can burn out cleanly, and of course now direct metal, which includes another 16 to 17 different materials. So there's going to be a lot of work and focus on materials in the next 10 years, and I think you'll see even more choice and selection as we move out over that time frame. Now, we also believe that people should not have to own the technology to take advantage of it. We offer cloud printing to anyone, companies to individuals. You simply upload your file, we'll quote it. We will help you pick out the material that's most conducive to your use, and then we'll ship that end product to your home or your business. And a lot of our very largest customers utilize the cloud printing service to either test new materials or to help them balance their workloads at specific times of the year. So a really good way of making it very, very accessible. So that's sort of where everything is today. But there's a lot of new opportunity coming up in this market. And I want to talk just a little bit about where it is going. High-speed, continuous manufacturing is going to be the next big thing, we believe. I'm going to talk about the consumer in a little while. This high-speed manufacturing allows us to do a couple of things. Really begin to compete more directly with traditional manufacturing where appropriate, injection molding, et cetera, but also to allow, through the introduction of a racetrack approach, the ability to hybridize manufacturing. These cars, and you can configure the machine to any number of cars, can go off track periodically for a pre or post-processing step, then get back on the track to be completed. This allows for a tremendous amount of differences in the way you produce, combining and hybridizing the manufacturing process, and a bunch of great new materials. So you're seeing some brightly colored objects here that were 3D printed using the technology. We think conductive materials and others will make this an amazing opportunity over the next 5 to 10 years for different companies to really change the way they manufacture and combine both traditional and additive manufacturing to get the best out of both. So we think that's going to be really, really powerful. Now, back to some of the great uses of the technology. Nike, about a year ago, introduced a custom sole that is meant to help runners get better traction and take off and actually perform better. And of course, that is courtesy of 3D printing. Really exciting application. I heard one of the other speakers talk about CAD and the development of objects online. CAD is one of the most complicated products in the marketplace. It's been around for 35, 40 years. And it's the only way we can create objects today to be 3D printed or to be manufactured. One of the other great opportunities is to really change the way the engineer's desktop works and give them access to new tools so that they can scan an object, get it into a CAD file format, and then 3D print it from there. They can also scan it and save it. You can take an old design that was never in CAD, recreate it, and bring it into CAD. Other tools are haptic devices that allow you to actually feel like you're working in clay and manipulate your file to create the best possible design. And we have a lot of those tools that are being made more and more available. So I think between scanning, haptic feedback, you're going to see some really amazing changes in the engineer's desktop in the next couple of years. And in fact, some of them are available now. Think about your eyewear. How many times do you use that and lose that little tiny screw that holds your glasses together? These were designed for 3D printing, so there is no screw. They have an ongoing, flexible hinge that was created because of 3D printing that makes them very easy to design, very easy to wear, and they will be form-fit to your face. Another wonderful opportunity based on 3D printing and access to these tools. I talked about a 3D printer that's under $1,000. We are pushing these out into the consumer environment now, allowing anyone to create and make in 3D, almost coloring book simple, and you're going to see more and more tools and kits available for companies to pass down to their employees, to put on the engineer's desktop, and for each of us to take home so we too can engage in the 3D printed lifestyle. A lot of fun, a lot of excitement there. And it gives us so many choices across our lives, including fashion, footwear, different watch bands. My ring is 3D printed. My iPhone cover is 3D printed. So it really opens up design to lots and lots of people. Hundreds of millions of people can now make choices and decide how they want to utilize and wear their 3D printed lifestyle.
From an idea to a product in a day.
This is kind of fun because what happens in the world in the future if instead of traveling and carrying all of your luggage and stuff with you, you're able to send a file, and like I was heading to Germany, instead of carrying my bags on the plane, I get here, my clothes, my watch, my shoes, and the bag itself is all 3D printed. The file is electronic. It can be used anywhere, anytime, by anyone that's authorized to use it. And when I get to Germany, I literally walk in, they hand me my bag, and all of my items are in there. They're fit for me, they're personalized for me, they're in the colors that I chose, and they're all available because it's just an electronic file, right? And this begins a whole story on a digital thread where you can go back and forth from the virtual world to the physical world on demand, whenever you want, whenever you need. And that's going to allow not only a lot of this fun on this Internet of Things, but it's going to allow all of us to live life a little bit differently and live it the way we want to live it and how we want to live it and when we want to live it. Now, I did carry my bag this time, but this is coming soon. This is just around the corner, believe me. So you name it, taking 1,000-year-old creativity like pottery, including it in a 3D printing scenario, and now you've got beautiful ceramics, and once you've found a piece you love, you simply reprint it. It does get glazed, it does go in a kiln, so we haven't taken away all the processes, but we have allowed you to take 3D printing to the next level. Entertainment, almost every character in a fast-moving movie today has been scanned, and it's their digital image that is taking all the risks. Trust me, it is not just a body double or themselves. And that allows us to create the collectibles and the products that then subsidize the revenue for that movie. So entertainment is a big user of 3D printing. And what about food? Are we going to be able to eat differently in the future? Are we going to be able to create specialized products to share with our friends and our family to really enjoy life in a different way? Are the chefs going to be able to create a beautiful cake in hours and then repeat it when they get special requests instead of spending weeks to create something? And oh, by the way, there's no reason why you couldn't use this in drinking and your various mixologists. These beautiful cake toppers were 3D printed, and they taste delicious. This is the beginning of 3D printed food because we believe that ultimately we'll be able to do customized nutrition for you using 3D printing. But for now, we're just going to engage in a wonderful celebratory element of how we live using 3D printed food, edibles, chocolates, etc. It's going to be really, really important for us to teach a new digital literacy, to get our children involved in that whole paradigm of going from virtual to real and back again, and start using 3D printing. We have found from as young as 5 and 6 years old, when the children get exposure to the 3D printer, they get so excited, they take to it like a duck to water, and they start creating new ideas on what they're going to build in the future. So it's pretty darn exciting. Now, this is Sally Dunn. And what she's telling you is she's an entrepreneur, and she had an idea one morning, and she wanted to bring it to life very quickly. Her idea was a clip that would allow the customer to put flowers and decorate their bicycle or other type of vehicle, their scooter, etc. What Sally did is she designed the clip. She 3D printed it on her home printer. She went to the flower market and bought lots of flowers. And within a couple of hours, she uploaded all of that to Etsy. And by 6 p.m. the same night, she had about 50 orders. And Sally knew she was onto something, number one, but she also knew she was in trouble because she couldn't print 50 and 60 and 100 and 200 of these clips. So what she did after getting into the market is she uploaded that same file to the cloud, and we 3D printed 1,000 of them for her in 24 hours and sent them to her home. So she literally went from idea to the marketplace in 24 hours. So all of the barriers to creating businesses, to entering businesses, are now lowered for anyone with an idea. And I think that's very, very exciting. So when you think about the technology, what I'd like to ask you to do is think of it as a digital thread. And this is your thread. And you can do whatever you want with it as long as you find a way to capture your idea and then create something. You can print it or you can save it and store it. But the important thing is to provide it to someone, to make it usable, and that digital thread will then store that file and make it available for you to reuse, reprint again in the future. And if you think about that, that's the real power of 3D printing. And that's something that's available to all of us today. And I'd like to thank all of you for your attention and for letting me talk to you about my favorite topic, 3D printing. Thank you.
Excellent, Cathy, excellent. Now, I've got one question, though.
Okay.
Okay, the bag you showed us, right? When you
Yes.
fly somewhere, you send your file. That is a great idea. But, I mean, I was telling Thomas sitting down here in the front, it looks all like cheap plastic that the stuff's being made out of.
Oh, no.
It looks like the Walmart version of the future.
Actually, I'm glad you brought that up. But now, how many of you recognize that 90% of what you own today happens to be made of plastics, nylons, etc.? That's how we live, boys and girls. My ring here is 3D printed. Does that look like cheap plastic?
No. I mean, if
Okay.
it did, I still wouldn't tell you. No, I'm just kidding.
You're a smart man.
No, I'm just kidding. No, it looks good.
It looks good.
But the picture, and I've seen this before in videos of things that are printed with 3D printing. There's something about them that still looks cheap. I mean, is it just me, or do you guys agree? See, look at everyone's nodding. I mean, this here, for example, this looks really nice.
Thank you.
But this looks like a completely different class compared to what was on the screen.
Well, this is direct metal. What was on the screen is nylon printing. But let me tell you, that nylon printing is absolutely beautiful.
It's really nice.
So what most of us get to see in our lives is ABS, PLA printing, because that's the standard in extrusion-based printers, which are widely out in the marketplace today. That's relatively inexpensive, and it looks cheap. It's plastic. It's beautiful Lego-like plastic.
Yeah.
But you have 120 different materials to choose from, and your outcome, including a beautiful full-color model of a home, can be anything you want it to be as long as you pick the right material. And with all those choices, you definitely can do that.
What about shoes, for example? Because I know traveling, I mean, I have a good-sized foot, and I hate carrying shoes because they take up so much space.
That's right.
Is that something in the future we'll be able to say, okay, I'm going to stay at this hotel. When I get there, they'll print out my shoes for me?
Absolutely. You know, and the women that have to carry the extra bag for the shoes,
Sure.
her life has been changed forever.
All right.
Now, you're all going to choose how and why you use 3D printing, but that's certainly one of the exciting options in the future.
It's fantastic, fantastic.
Absolutely.
Any questions for Cathy before we go into the lunch break? What about printing food, by the way?
Oh, we love it. Chocolate in beautiful figurines.
What about gummy bears?
Gummy bears, yes, we can do something like that.
I think that's great. I'd have one at my house every day.
Pretty much anything you can imagine.
Yeah.
And I think yours is going to have some extra energy boost in it, right?
All right. All right, good. Let's give Cathy a round of applause.
Thank you
Excellent
so much.
presentation, Cathy. Thank you.